And welcome to this talk about Talos Linux, which is an emerging container technology with a keep it simple, stupid philosophy. It's meant to run Kubernetes in a secure and highly available manner. My name, outside of the Netherlands, is Oomen. I do live in Norway, but I'm originally from the Netherlands. And in the Netherlands, I'm known as Pepijn. I'm a platform engineer at Red Bull Pro in Norway, and we are the open source company for the Nordics. I was just recognized by the Linux Foundation as an Kubestronet, which is a completely different talk, but it was a fun journey as well. Red Bull Pro is building the Nordic digital society. This is a landscape of what we're trying to do. We're based on open source technologies. My role is in the cloud. I'm part of the cloud ops department of Red Bull Pro. Originally Linpro in Norway, Red Bull in Sweden. The Swedish part bought the Norwegian part in 2008. And now we're known as Red Bull Pro AS, operating in Norway, Sweden and Denmark. So what is Talos Linux? Talos Linux is a Linux distribution specifically built to run Kubernetes. And to reduce the attack surface, it is minimal, and it is immutable, and it is hardened. It's open source and considered production ready. All management is done through a gRPC API, and all access is secured with mutable TLS. It has no shell, and therefore it has no interactive console. It is meant to do one thing and one thing only: maintain a Kubernetes cluster. The real power of Talos Linux is to operate a cluster of machines. It does this with lots of checking and coordination between all the individual parts. There's a single objective, and that is the cluster. Talos Linux attempts to be completely self-healing, like Kubernetes, and if some part, a single service or a complete machine misbehaves, then we just turn it off and on again. The next step would be to cut out misbehaving part or replace it. You should not get stuck with a single misbehaving component or a machine. The ultimate in no-flake computing, and I'm not talking about flakes like you talked about flakes in the previous talk, but these are flakes for snowflakes and no flakes. Talos Linux is not based on any other known Linux distribution. You can think of it as a sort of second generation container-optimized operating system. CoreOS, Flatcar, Rancher are the first generation. Talos Linux is the second generation. It is not a technological derivative of any of those, though. It does reuse the Linux kernel, but everything in user space is written in Go from scratch. And this is then regularly tested, and the final product is shipped and published as a signed and versioned image. The Linux kernel doesn't launch systemd, but it launches machined, and this is your PID 1. To keep everything to an absolute minimum, Talos Linux comes without a shell, without SSH, and none of the traditional GNU utilities, not even BusyBox. Everything is there because it is necessary. All bloat is removed. As a result, the image is about 80 megabytes and contains 12 unique executables as of version 1.7. Talos CTL, which is an external management utility, does provide an array of basic troubleshooting tools using the API. If you do need any additional troubleshooting tools, you can do those by starting a debug or a utility container with elevated privileges. Talos Linux takes immutability to a next level. It runs from a squash FFS image, and as a result, the image itself is never modified. All images are signed and delivered as single and version files. These files contain an immutable and verifiable image. Built for all components, the kernel, init ramfs, Talos CTL, the ISO image, and the container images are all reproducible. Talos Linux does allow a few highly controlled write mount points, but those are as non-unique and non-critical as possible. This implies that you need to make sure that the writable areas are not used for unique, non-replicated, non-recreatable data. So don't have state on a machine. Talos Linux has been designed with security in mind. and therefore bypasses a huge class of vulnerabilities. The images being used are always signed and can therefore be confirmed to be authentic. There are no passwords being used in Talos Linux at all. All network communication is encrypted and authenticated with keys and certificates. The certificates being used by Talos Linux are short-lived and rotated automatically. That's a key point. Kubernetes is always constructed with its own and separate PKI infrastructure, which is enforced and also automatically maintained. Talos Linux takes advantage of a number of additional settings, such as recommendations of the kernel self-protection project, and completely disables dynamic modules. As mentioned earlier, no writes are allowed to the vast majority of the file system. The writable partition is called ephemeral to emphasize that it contains only replicated or reconstructible data. If all else fails, we just wipe the disk and get back up running from a virgin state the image, just like we do with the regular container technology. All configuration in Talos is done through YAML manifests, just like we used to from Kubernetes, for better and for worse. There's no scripting and there are no procedural steps. Everything is defined by the declarative YAML, eliminating all imperative configuration. Talos Linux is intended to be operated in a distributed manner. It is built for a highly available data plane. Its etcd cluster is built in an ad hoc manner, with each member joining the cluster with proper security enforced. Like Kubernetes, workloads are intended to be distributed across any number of nodes. There should be no single point of failure, and the level of required coordination is as low as allowed by the platform you run it on. We can run it on a large number of systems, and I'm just mentioning a few of those. On bare metal, we can start it from ISO image through PXE or use secure boot. Virtualized, we can of course run it on KVM, Hyper-V and Proxmox. In the cloud, we can run it on AWS, Azure, GCP and OpenStack. Locally, we can run it through Podman and Docker or QEMU. And single board computing is a very popular choice for the hobby community. Raspberry Pis, Banana Pis, Pine64, and the list goes on and on and on. This list is constantly being extended. Following the community online, you'll get a view of what they try to achieve on extra hardware. If it's not running on hardware, they challenge you to help them figure it out. And I'll give a small demonstration of some hands-on creation of a Talos Linux cluster. Start out with a multi-node configuration on OpenStack, which is the cloud that we at Linpro run in the Nordics. And we'll additionally show how to initialize a single control plane, single worker node on my local machine using Podman. I also will show how to upgrade a node and how to roll back again to a previous release. For the OpenStack demonstration, the secrets were initialized with the first command, talosctl gen secrets, and this eases the reuse of those secrets for later usage. You should take very good care of those secrets because they are what they call secrets. They include private keys and stuff like that. We then generate the necessary configuration files for the control plane and the worker nodes using the generated secrets. And we do that with the talos gen config. OpenStack is just a name, and then a URL that we're going to pay a point to, and the reuse of the file secrets YAML. This results then in the 3 files that we use for initializing the system. The nodes were pre-created using those commands, where we use the user data, which points to the separate types of control files that specify the machines. I'll be using Talos 173 and not 166 because this was released recently. I didn't update the slides yet. I just noticed now. So let's do some demoing. Let's hope that everything works at the same time. Let's have a look at the layout of the machines that we have rolled out. Using the command OpenStack server list, I see that I have 5 machines. They are turned off, not running. They are empty. They were just provisioned and then immediately turned off. So let's start by starting them. So I use this one-liner to start all the machines that I listed up there. While this is starting, let's start also a cluster locally. I use Spotman on my local machine. It's Spotman 511, running on an Apple Silicon Mac machine. And I use the talos command using cluster create to just start the cluster. This takes some time, so I do this in the background while we go back to the other session. Let's look at the status of the servers. They are now active. It's a good sign. And if you now look at the configuration for my Talos CTL installation that I'm running here, we see that I have a number of nodes. This was pre-configured because I knew where the nodes were, so it's not completely from scratch. You see when it was created, 26th of June, 12th of June, so that's a few days ago. And then it's a year validity in the certificate there. And if we now look at the members that the cluster finds, and there I used a single node, the control plane 0 node, I'm gonna query for the members that it sees in its cluster. I could use this for every node. I'm just using the first one, and we see that we have 5 nodes that are now active running first version 173 with the different information on the machines. If we look at the services that this node is providing, we'll see that it's basically okay, but there's one that's preparing. The etcd node is not starting off itself. Because we're running a cluster, we need to give one of the machines the command, you are the one that takes charge of the rest. We just do this one time by running the bootstrap command. And if we do bootstrap, and then look at the status of etcd, wait a little bit, and now look at the status of etcd, we see that it is now running. And if we look at the output of the kernel logs, we see that it has now started etcd running. So now we actually have an etcd startup on one node, but the other nodes notice this and have joined the cluster. So we now have a 3-node etcd cluster. I did only one thing. I started the machines, 2 things. I started the machines and I bootstrapped the etcd cluster. If you now look at the command dashboard, we'll get an interactive view of my cluster. You see the nodes in the bottom, the 5 nodes I have. And here we see currently the lighting is not completely showing that I'm on control plane 0, but you see that in the top, which version, what the status is of the several components that which the cluster is consisting of, and the live logging of the machine. We can use the arrows to go through those and see that there's live logging from all of those. We see that the worker 1, we're now at worker 1, that actually the kubelet is now healthy, and the state is running. It's not ready yet, it will be soon. It's now, all the 5 machines are now bootstrapping themselves to become a part of the cluster. If we use the F2 button, we get live metrics from the machines. Which process is running, load averages, network usage, disk I/O, CPU usage, memory usage. All your essentials are now showing here. If you have a cluster of 30 machines, 100 machines, this is not scaling. But for a small cluster and getting known some information on selected machines, this is a very nice feature, not requiring any extra utilities, just kubectl. A Talos CTL. Sorry. This is node 1, node 2. We now see that the control plane 2 node has healthy for its kubelet API server, controller manager, and scheduler, the necessary processes for a basic Kubernetes cluster. We see that this is actually ready as well. If we look at the other ones, they look all fine, actually. And this one as well. So now we have a cluster up and running. 5 nodes, everything should be fine. Let's inspect. To actually be able to use kubectl, I need to retrieve the kube config. The kube config can be retrieved through Talos CTL from the cluster. So when you need to provide access for someone to access your clusters, they just need the Talos CTL access and can bootstrap themselves from there into the system. So now I have a kubeconfig file locally, and if I now run a kubectl cluster config, I see that I have a cluster running on that URL with the core DNS running. If I look at the nodes, you see that I have 5 nodes, all running 173, and this is your basic kubectl node information. Let's also look at the pods, which a typical clean system is running. We see that it is running all your known necessary pods within the kube system namespace, and we see that I didn't change anything. It's by default running kubeflannel, which is the default CNI it installs. This is something that you can change by making sure that the data you inject into the machine when it boots is adjusted. Do not use a CNI. I usually use Cilium, actually. But in this demo, to keep it simple, I just use flannel. It works fine for this demo purpose. If I use this command, containers, I look at the containers at the operating system level. I do this for worker 0, which is a bit boring because it's only showing 1. This is the API entry. This is the one process that is maintaining all your nodes. It's running on all your systems. The control plane nodes have an extra process because they have the access from the outside. This is the internal access process that's running as a container on the system. So it's not something that's extra, it's running as a container on the system. If I use the -k option, in addition, I get the Kubernetes containers that this machine is running. So we see here the typical 2 containers for a pod. There's the management container that runs the pod, and there's the containers that run in the pod. This is a minimal system. It's not running any workloads. So we're not expecting any more. If we now look at the podman, it has initialized itself, and it comes with the result that it should have now 2 nodes, a control plane node and a worker node. It has generated the kubeconfig for me, so I don't have to retrieve the kubeconfig. I can just immediately run kubectl. This is now configured to access the cluster on my local machine. So I use different kubeconfigs for different environments. We see this is also running the same information, we get back the same type of information. This is on localhost. If we look here at the nodes, we see that we have 2 nodes running on 174 because this is the latest version. I installed 173 on the other one because I also want to show you an upgrade. So I installed one previous version. And if we look here at all the pods it is running, we basically see the same thing, but just for 2 nodes instead of for 5 nodes. 1 control plane node, 1 worker node. If we now look at an upgrade process, typical upgrade process, because this is the thing that for me was a game changer. I used to run Kubernetes using kubeadm on Debian. I like Debian, I like kubeadm. It's pretty light and nice to do, but you have to have a relation with Debian, update, upgrade, and the whole process there. It's sort of silly. If the only thing you're interested in is running containers, why should you have an active relationship with your operating system you're running on, where you have to have separate procedures for upgrading your operating system? What I'm going to show you is to upgrade a worker. Usually you shouldn't start with upgrading your workers. You should first upgrade your control plane nodes and then upgrade your workers. There is a management interface for all of this, which is sold as a commercial license by Sidro Labs, who are making Talos. But now we're looking just at the open source version, which doesn't have this, so we do this manually. And the way to do this, you might have guessed, Talos CTL, which node we're going to upgrade, upgrade. If I upgrade, it downloads the newest image onto the node. It installs it in the separate partitions. It has an A partition and a B partition. It makes the active boot partition B, boots from that, and you're basically done. Since it is not storing any critical persistent data, you don't really have to worry about it. You could just replace the node and upgrade it with a new image. This is something I discussed with Pulumi yesterday, how do we roll out stuff in a more smart way when we're talking about big clusters and images. But this basically works fine. So let's start the upgrade. Here we see the logging. It's validating the images it downloaded. It is encrypted and signed. It then starts to drain the node for removing all running workloads from it. It coordinates the node, it drains the node, or it coordinates the node, it removes all pods like you usually do when rebooting a machine. It shuts down and then just boots again. It's booting up again. On the top you get live status from the upgrade command itself. And as soon as it is done, boot sequence done, it gets the feedback and now it's upgraded. If you look at the nodes, we see there's one node that's now on 174. Again, this is not the way you should do it. You should do your control plane nodes first, but minor versions usually works. But I have failed this process live when I did an upgrade first of the worker nodes and then the control plane, and it didn't work. But for demo purposes, it works. Upgrading Kubernetes, it's at 31. There is 32 now. There's a separate command, not going to show that, upgrade k s, and that's just going to upgrade your Kubernetes version to the version you want. And you can also downgrade and upgrade. So that will just upgrade your control plane nodes and upgrade the controller, the scheduler, the API server, and then go out and upgrade the kubelet versions on the nodes as well. If we now find out that this node's not performing as it should, we use the rollback command. Do notice that rollback does not do a drain. It just reboots the node. So it will be very fast. It's booting. Since you roll back in a crisis situation, you probably have a good reason to not do the whole drain process. Wait a little bit and then see if it comes back. It's coming back already. Boot sequence done. Let's see if it actually did something. It's back in 173. For me, this was a whole new way of using Kubernetes. I'm running this at a large site in Norway with really, really good results. The developers do not really notice that we're doing anything different in the bottom. They run Kubernetes applications on the Kubernetes platform. But for us as operators, this really was a great way of making things simpler and, not the least, more secure. Fedora CoreOS, Red Hat CoreOS using OpenShift is an alternative, but you still have SSH into the machines. So the biggest complaint from my colleagues is, I want to SSH into the machine because I need to reboot it. I don't see the point. They just need to adapt to a new life, way of living. To close off, here's the links. The first one is the most important one. Just remember Talos Dev and you get all the other links there. Talos is a product from Sidero Labs. Talos itself is open source. Sidero Labs is a silver partner of the CNCF. They did not make Talos a sandbox in the CNCF yet. I'm trying to push them to do that because I think it's important enough that the base system should be a part of CNCF and CNCF policies. The latest version documentation is found on the version, and this is my LinkedIn QR code, which should work out. Thank you for your time. Any questions?
Yeah, thank you very much, Pip Oomen.
There was one question.
Yes, a question? Okay.
Hi. First of all, thank you very much for your presentation. It was very informative and very impressive, especially MTLS part on the API. I have actually two questions. Am I right to assume, as the file system is read-only, that it comes with specific Kubernetes version baked into the image? And for upgrades and whatnot, you have to have the image there, the new image.
The image is not part of the file system. It's a container that's run. So
Okay.
the kubelet itself is fixed. No, not even the kubelet. No, everything is containers. It just what it can do is start containers. And then when you start it up, it downloads an image for the kubelet, which is the version you're running. And the same for all the others. So it's running everything as containers.
So I'm not tied to TalOS for running Kubernetes specific version.
No, you can just. I run with 1.7. I run 128, 129, 130, basically all three. There is
that was the question, actually. I wanted to understand how, if we are tied to TalOS to manage the Kubernetes versions, how behind we should stay.
There are some issues there that the newest version, you need the newest Talos. So when a new version of Kubernetes is released, 1.7 was released because 130 was released.
Okay.
So you can't run 130 on 1.6. But backwards compatibility is there.
All right. And the second question would be, I saw you specified a specific node to upgrade. Is there a possibility to not specify node or specify several, that it will run in parallel, or it has to be one after the other?
The upgrade I do for our internal cluster is I take all control plane nodes not simultaneously, because then you lose your control plane. So you take control plane 1, control plane 2, control plane 3, and then we have 3 data centers, and then the next step is that I take all other nodes in a single data center simultaneously.
Okay.
So by just specifying multiple nodes on the command line.
So the minions is possible to upgrade in parallel.
I did try just running upgrade without specifying anything. That's not quite working. It tries to keep your control plane won't really reboot, but the best way is just be in control, or, and this is the Cedro Labs answer, use Omni, which helps you in doing this. That takes care of that. Then you just say update my cluster, and it just makes sure that everything is upgraded in the correct way without you having to do anything.
Thank you very much.
I do want to say that Omni is a business source license, so you're actually allowed to use it on-prem as long as you do not do it for production. But you're allowed to play with it. Yeah.
Okay, are there any other questions from the audience? No,
if there's anything, just catch me afterwards. I'll be a little bit longer on site. Thank you.
Thank you very much.